morning everyone. I'm Dr. Shalini Hanok, Associate Professor, Department of ECE, ATME College of Engineering, Mysore. Today I'm here to explain the third experiment, that is of Communication Lab of 22 Scheme 22 ECL 404, test of balance modulator. Balance modulator is basically one of the type of amplitude modulator. So there are different types of amplitude modulator, that is DSPSC, SSBSC. So these are the different types of amplitude modulators. So we have a balance modulator which generates DSPSC signals. A balance modulator is a circuit that generates a DSP signal, suppressing the carrier and leaving only the sum and difference frequencies at the output. The output of the balance modulator can be further processed by filters or phase shifting circuitry to eliminate one of the sidebands, resulting in a SSB signal. DSPSC signal is double sideband suppressing carrier signal, and SSB is single sideband suppressing carrier signal. So the different types of balance modulator ICs we have in the market is IC 1496 or 1596, and it is the analog multiplier. So here in our experiment we will be using IC 1496. So balance modulator, again if you have to describe about it little briefly, so it consists of two identical AM modulators. These two modulators are arranged in a balanced configuration in order to suppress the carrier signal. Due to the suppression of the carrier signal, the output consists of only the upper and lower sidebands only. So we have, before going to the balance modulator circuitry and all, we have to first of all basically know what exactly is double sideband suppressed carrier transmission, which balance modulator does. So DSPSC is an amplitude modulated wave transmission scheme in which only sidebands are transmitted and carrier is not transmitted as it gets suppressed. We are going to suppress carrier and we are going to transmit only the amplitude modulated wave. So the acronym of double sideband suppressed carrier is DSBSC, larger bandwidth. The application of DSBSC modulation is during the transmission of binary data. DSBSC system is used in phase shift keying method. In order to transmit two-channel stereo signals, DSBSC signals are used in television and FM broadcasting. DSBSC techniques allows us to have a transmission that reduces overall power consumption rate, thereby ensuring a stronger signal at the output. So this is the basic block diagram of a balance modulator which generates DSPSC signal. We have message signal, and we have the 180 degree phase shifter here, and we have a local oscillator for generating carrier frequency, and we have the two more AM modulators here, so which are going to be mixed up here or summed up here or subtracted here. So here, from here we are going to get the signal, message signal, and here we'll have a not shifted waveform. So we have a 0 degree phase shift waveform, and here we have a 180 degree phase shift waveform. So after it crosses the AM modulator and it gets mixed up with the local oscillator, so here we are going to get the two summed up waveforms getting from the phase shifted and from here we are going to get a 0 degree phase shift. From here we are going to get a 180 degree phase shift, so which will be summed up here, and finally we will be getting a signal S of t, which is DSPSC signal. This is the pin detail of IC 1496, which will give us a DSPSC signal, And here we have pin number 1, which is the signal input, and we have pin number 10 and pin number 8. Both are meant for carrier input. So here either of the one we will be using. If we are using 8, then we will be grounding 10. If we are using 10, we will be grounding 8. Then we have this pin number 2 and 3, which is a gain adjust. Since we want a higher gain output, so we are going to connect a resistor between 2 and 3 so that we will be getting the higher gain output. And here either pin number 1 or 4 or in between them, we will be providing the inputs using a bias circuit. And here we have pin number 5, which helps us to provide the biasing needed for the circuit, and we have pin number 6 and 12, which is meant for output, and we are supposed to give VEE, that is the power supply, which is given to pin number 14, and pin number 13, 11, 9 and 7 are not connected. And this is the pin detail of IC1496. So IC balance modulator, that is IC1496 or 1596 IC, is a versatile circuit available for communication application. It can work at carrier frequency up to 100 MHz. It can achieve a carrier suppression of 50 to 65 decibel. And the 1496 IC or 1596 IC can operate as a balance modulator or configured to perform as an amplitude modulator, a product detector or a synchronous detector. This is a block diagram we have designed in the lab, and we will be implementing this. So as I told you in the pin detail, pin configuration of the IC, pin number 2 and 3 are gain adjust. Here 2 and 3 are adjustable gain, and we are going to connect 1 kilo ohm resistor so that it will provide higher gain. Then we have this inputs carrier given to pin number 10 or pin number 8. Here we are using pin number 8, we are using pin number 10 for providing carrier frequency. That's the reason we are grounding pin number 8. And pin number 1 is the signal input, and there we are providing the M of T, that is the message signal is provided this to pin number 1 using this bias circuit. And this capacitor is the coupling capacitor, and we have this 22K and 22K, which is between pin number 1 and 14. Pin number 14 is connected to VEE, that is supply, so negative supply. So here it is. So through this biasing circuit, we will be connecting it to negative supply for negative drift of the amplitude modulator, and between pin number 1 and 4. So we have this pin number 1 and 4, we are providing signal input. So the signal input is provided through pin number 1 and 4 using the resistors 47 kilo ohms either end for the getting a better AM modulated signal. Here we have pin number 6 and 12, which is a output pin. We are going to get the output through these two pins using resistors 3.9K and 3.9K connected here, and finally it is connected to plus 12 volts. This is the since we are getting signals both at positive ends and at the negative ends, we need dual DC supply voltage, that is plus 12 volt supply to get the higher positive end signal, and plus 12 volts for negative end signal. So finally we will be connecting the pin number 5, which is the gives the biasing point. So So pin number 5, to maintain the biasing in the circuit. That's about the circuit detail. This is a waveform we are going to get at the output. So this is the message signal, this is the carrier signal. Finally we will be getting the signal, DSPAC signal like this. So wherein, see, this is the positive end and this is the negative end, and this is the suppression of carrier. So here where the suppressing of carrier is happening, so wherein we have the normal AM modulated signal, we do have this carrier being increased according to the modulation index, but here the sidebands are totally suppressed. That is, carrier, the sidebands of the carrier present in it is suppressed, and we have a phase shifting taking place here. So this is how DSPAC signal looks like, and we are going to get this as the output. Thank you. Now we are going to practically see in lab how these signals are generated. Now we are going to see how this balance modulator works. The main component for this particular circuit is this IC1496. This is called as balance modulator IC, and there are different components which is used. This is how it is connected, and we have various components which has been explained in the circuit diagram. Here we are going to connect message signal. So this is the message signal which is connected through capacitor, coupling capacitor here, and this is the carrier signal. This is a carrier signal which is connected to pin number 10. So it is going to generate the DSPAC suppressed signal on waveform. We are going to get like this. So wherein the DSPAC in the sidebands are suppressed. Here we can observe that the suppression of the double suppression here and here, double suppression of the carrier is seen both the ends, and we have a phase reversal here happening. So the phase reversal and carrier suppression is happening here. This is how balance modulator or a ring modulator waveform looks like. Thank you.